Welcome to the quick brief on the blended total precipitable water TPW. The product application video will demonstrate the utility of blended TPW in the operational forecasting environment. The main learning objectives are to identify data sources and resolution of blended TPW and how it differs from ghost TPW. Interpret and understand the value of its counterpart, the percent of normal TPW product. Demonstrate blended TPW's primary applications that include identification of atmospheric rivers that can lead to heavy precipitation and flooding, and discern moisture gradients that aid in severe weather forecasting. And lastly, recognize blended TPW's limitations that contain irregular data sampling, no microwave retrievals within regions of precipitation, and the blended TPW is identified as a non-advected product that only provides column TPW measurements throughout the atmosphere. Total precipitable water, or TPW, represents the liquid water equivalent if all the water vapor within a column of the atmosphere were condensed, typically shown in the unit of inches. The blended TPW product uses a blend of data sources. Over water, the product uses microwave data from polar orbiting satellites. Over land, it uses data from both the Surface-Based Global Positioning System, GPS, and geostationary satellites. A blended TPW example is shown, observing an atmospheric river that led to heavy precipitation and flooding near central California on 20 March 2018. High moisture content greater than 2-inch TPW values is depicted in the red and purple colors. The product exhibits near global coverage, covering from 71 degrees north to 71 degrees south, has a 16-kilometer spatial resolution along with an hourly temporal resolution. Blended TPW can be used in complement to the GO16 TPW product to identify moisture content and moisture distribution. A case example is shown in the southern U.S. on 13 August 2019, where the same color table is applied to both products. As I toggle back and forth, note GO's TPW is limited to clear sky environments. Retrievals are not possible through clouds, and black pixels denote missing data. This makes for a blocky appearance in the imagery. The advantage of blended TPW is that retrievals are possible in cloudy regions. However, blended TPW is not available as frequently as GO's TPW, where the latter exhibits a finer spatial resolution of 10 kilometers. In this example, within the cloudy region, precipitable water values of 2.5 inches are noted in the blended TPW, but are not shown in the GO's TPW. Highlighting the same atmospheric river event over California, the percent of normal TPW product is shown, displaying the percentage departure from climatology. Normal TPW values are based on NASA's Water Vapor Project NVAP 1988 to 1999 climatology. The product highlights the significance of atmospheric moisture in the region where near climatological normal TPW values are depicted in white, above normal or wetter values in aqua and yellow, and below normal or drier values in brown. In the imagery, Central and Southern California were above normal at the time and experienced extensive flooding from the event. The following slides show the primary applications of the blended TPW product. As noted before, the product identifies atmospheric rivers that exhibit rich moisture plumes that can lead to heavy precipitation and flooding, in this case over Southern California. This example illustrates one of the best uses of TPW, showing precipitable water patterns over the ocean where there are limited surface and upper air observations. Another application is the identification of moisture gradients for severe weather forecasting. A 20 May 2019 blended TPW animation with surface observations overlaid show copious moisture in the Gulf of Mexico, advecting into the Texas Panhandle, Oklahoma, and Kansas. High blended TPW values greater than 1.5 inches and above normal TPW values greater than 150% indicate increased flooding potential where the moisture plume/gradient supported development of heavy rain, hail, and tornadoes across the plains that day. There are limitations of the blended TPW to keep in mind. Since several satellite data sources are integrated into the product, the timestamp displayed does not represent the time that all data are sampled. Microwave data are updated irregularly due to differing orbits, resulting in imagery that appears blocky over the oceans when animated. Microwave retrievals are also not reliable in areas of heavy precipitation or where there is snow cover. These areas of missing data appear black in the imagery and shows that the product does not cover high latitudes well. In contrast to microwave, GPS data over land is updated hourly, exhibiting a smoother appearance in the animation. Blended TPW is a non-advected product. This means that the model winds are not implemented into the algorithm to advect moisture. And lastly, blended TPW only determines the total TPW throughout a column in the atmosphere and does not differentiate moisture content of specific layers, for example, surface to 850 millibar. Blended TPW primarily includes low Earth orbiting and GPS data sources to provide moisture content and moisture distribution for forecasting applications. The product continues to evolve, where GOES 15 datasets will be turned off soon. However, GOES 16 and GOES 17 datasets and advection techniques will likely be incorporated in the future.